So again, this box plot has to do with visualizing your data set. So let's say we have a data set that has these numbers. Okay, so if you have this data set, for example, let's say they represent grades, and you want to construct this box plot to summarize that data set. So let's go ahead and do that real quick. So the leftmost component of the box plot is going to be the minimum value in the data set. What's that? 41. While we're at it, let's identify the max. 97. This data set happens to already be sorted, so that's convenient, but if it wasn't already sorted, then it would help if you sorted it first. So now let's identify the next component, and what's that? Yeah, that's going to be P25, which is the value that can be inferred from the data set that represents the 25th percentile, where that's greater than 25% of all the values. So again, we're not restricted to a number that's already in the data set. It could be inferred from the data set. So we can use that formula we talked about to find P25. The formula is the rank of the answer is n plus 1 times the percentile. And what's n in this case?
9.
Yeah, 9. So it'll be 9 plus 1 times the percentile as a decimal. So percentile as a decimal is 0.25. So we're getting 10 times 0.25, which is 2.5. So that's not the actual answer itself, it's the rank of the answer. So it's the position of the answer. So if you were to rank these numbers in order, after they were already sorted, then these would be the ranks. So we want the number that is in the 2.5th position. So the number in the second position is here, the third position is here. So the number in the 2.5th position would be the average of the numbers in the second and third positions. So now we're going to add 52 and 57 and then divide by 2. 54.5, great. So, and essentially the average of those two is just the midpoint of those two. So it's the number that is the same distance away from 52 as it is from 57. Okay, so this P25 ends up being 54.5. Any questions?
Why is it not 31?
Oh, because after using this formula, we got a rank of 2.5, which just means it's in the 2.5th position. 41 would be, if this formula had given a rank of exactly 1, then we would use 41. Okay. So moving on, the next component here is P50. And we also said that that was the same as the median. So you could actually also calculate the median and get the same answer. So the median just means that you sort them and they happen to already be sorted, and then you pick the number in the middle position. So what's the middle position here?
66.
Yeah, it happens to be this fifth number where there's 4 numbers below and 4 numbers above. So it happens to be 66. So the median is 66. So that'll be the answer. That's one way that you can get it. Another way is just to use this formula. So the rank of the answer is n plus 1 times p. N plus 1 is going to be 9 plus 1. And then p will be 0.5. So now we're going to take 10 times 0.5. That'll be 5. So the rank here is 5, which is the 5th number. So you see that the fifth number is exactly the 66, which is the median. Any questions? Okay, so now let's look at the last component here, which is P75. So you want the 75th percentile, which is the number that is greater than 75% of all the values. That can be inferred from the data set. So again, we're going to use the same formula, n plus 1 times 0.75 now. And this will give us a rank of 7.5, which is the 7.5th number. So 7.5th number is the number between the 7th number and the 8th number, so we can take the average of those two. So the average of 72 and 78 turns out to be 75. Great. So that turns out to be P75. So that's gonna be 75. So we've circled all the components of this box plot here. All 5 of the numbers that correspond to the box plot. So the point is that you can just look at this and quickly tell what the extreme values are, the min and the max, and then you can tell where the bulk of your data set lies, which is between 54.5 and 75. Okay, any questions?